Okay, grade 8. Your last review question is from chapter 10.4 on distributive property. I think you have 8 questions, 10, I don't know how many questions, we'll see in a second. So in this equation here, 4 times x minus 2, it says equals 5. The constant on the left is negative 2, and it appears that it is negative 2, but it's not. The answer is false, and here's why. What distributive means is this says I have 4 groups of x minus 2. So if I was to draw that out, there's an x and a minus 2. And since this is 4 groups, I would have to quadruple it. So I'll take it, and I'll double it, I'll triple it, and I'll quadruple it, or multiply it by 4. And when I do so, I see that I don't have a minus 2 constant. I actually have a minus 8 constant. Now, another way we could have seen that is because this is the multiplication, I could have actually expanded it using distributive property to see that 4 groups of x minus 2 is 4x minus 8. And since this is the same, I can now clearly see that the constant in this equation is minus 8. So the constant, when I expand it, is clear that it's minus 8. In the second question, to model the equation 5 times x minus 2 equals 40, you would need to use 50 integer chips, positive and negative, to start. Well, if I think about what this would be x minus 2, so there's an x and a minus 2, and I have 5 of those, so I'm going to infinite clone that. So double it, triple it, quadruple it, multiply it by 5. I would have my modeling over here, and then I would have 40. Now watch this. Positive 40. 1, 2, 3, 4, 6, 7, 8, 9, 10. There's 10 of them there. Oh, hang on. Group, ungroup. Take these, group them together. That's 10. That's 20. That's 30. That's 40. That's 50. That's 40. Sorry, I don't need this one. Throw that one away. Don't need that one. But as you can see, if I was to model it, here I have 40. Here I have 10 more. So in total, I would need 50 integer chips to start, which means that's a true statement. I need 50 integer chips to draw the first part of this model. Question 3, it just says solve. So there's 2 ways you can do this question. Now remember, I'm going to just duplicate it here. So I'm going to take this and I'm going to duplicate or clone it, bring it over here. So the first way is to expand. So instead of saying 3 groups of x minus 1, I can say I have 3 x's and I have a minus 3 because I have 3 negative 1s. Once I expanded it, I can then add 3 to both sides to get 3x equals negative 3. Divide both sides by 3, and x equals negative 1. So you can see that this was the first step to expand. This was the second step, and this was the third step. So we're using 3 steps. I found that the answer was negative 1. But if I think of it a different way, if I think that there's an x and a minus 1, there's an x and a minus 1, and if I think of it x and a minus 1 equals negative 6, then I could say if 3 groups of x minus 1 equals negative 6, then each group of x minus 1 would equal negative 2. And what I did there is I took this whole side and divided it into 3 parts. So instead of 3 groups, I have 1 group. And instead of negative 6, I divided that by 3 as well, ended up with negative 2. So rather than ask myself, what is 3 groups of x minus 1, I ask myself, what is 1 group of x minus 1? And that's going to be negative 2. Then I add 1 to both sides, and x will equal negative 1. It's the same answer I got over here. It's just a little less labor intensive, right? Instead of asking the question, 3 groups of x minus 1 equals negative 6, I really want to break it down into 1 group of x minus 1 equals negative 2. And I do that by dividing both sides by whatever the multiplier is. Question 4, we have the same type of distributive property. I'll clone it again and do it 2 ways. So the first way you could have done it is expand it. So 5 groups of x minus 4 will be 5 x's and a minus 20. Get rid of your constant now, which is 20, and get 5x equals negative 10. And solve it finally by saying x equals negative 2. So there we had it in 3 steps. Now again, instead of saying 5 groups of x minus 4, I'm going to divide both sides by 5 to figure out what 1 group of x minus 4 is. And since 5 groups of x minus 4 was equal to 10, then each group of x minus 4 must be equal to 2. Add 4 to both sides, and x equals 6. Question 5. I will clone it again. On the clone again. I'm going to expand. So this time we have a negative 4 times x, which will be a negative 4x. And this is where it gets a little tricky for people. A negative 4 times a negative 1 is a positive 4. Okay? So when I expand it, this is what I end up with for an equation. Some people still think it's a negative there, and they forget that. But it's a positive, because a negative 4 times a negative 1 is a positive 4. Now I'm going to get rid of that positive 4. Then I'm going to get rid of the negative 4. And x equals a positive 4. We can achieve the same thing by dividing both sides by the multiplier. Negative 12 divided by negative 4 is a positive 3. So instead of negative 4 groups, I got one group. Simply add 1 to both sides, and x will equal 4. Same answer. Question 6 says model it. So two groups of x plus 4. Well, there's one group of x plus 4. And if I clone it, there's two groups of x plus 4. And two groups of x plus 4 is equal to 6. So I'm going to add a negative 4 and a negative 4, or negative 8 to this side. If I add negative 8 to the left, I have to have negative 8 to the right. When I do that, that becomes all 0 pairs. 2x's is equal to, those are all 0 pairs there, negative 2, which means that each x is equal to negative 1, or x equals negative 1. And finally, the last question says 10 students are going on a field trip. Each student takes $3 more than they needed, and in total they have $70. How much were they supposed to bring each? So if we say that x equals the number of dollars they were supposed to bring, the first thing we want to always do in these questions is define our variables. X is going to be the amount of money they were supposed to bring. So each student brought $3 more than they were supposed to bring. So that is going to be the expression x plus 3, because it's $3 more than they were supposed to bring. And if 10 students brought that, I would have to multiply this amount by 10, because each student brought that multiplied by 10, and in total, that became $70. So now I've achieved an equation that I can solve to figure out how much they were supposed to bring each. I divide both sides by 10 because I want to do it the simple way. I'm not going to expand it. And that means that each x plus 3 will equal 7. I'm going to subtract 3 from both sides, and x will equal 4. So therefore, they were supposed to bring $4 each. End of story.